Simpson rule for approximate integration. Instead of using straight lines to form rectangles or trapezoid in left sum, right sum, midpoint rule, and the trapezoidal rule, a more accurate method is the Simpson rule method, which replaces lines with parabolas. Using two consecutive intervals, x1, x2, for example, and then x2, x3, using the 3 points in the two intervals on the graph, we fit a parabola that goes through the 3 points. The area under the parabola within the two consecutive intervals will estimate the area under the curve within the same intervals. We then move on to the next two consecutive intervals and fit another parabola, and we keep doing this until we get to the last two intervals. Because of this, we need to have an even number of intervals when we use the Simpson rule. The computation or the formula for the Simpson rule can be derived by taking any representative parabola and shift it so that with the 3 points we position the middle point at the origin. A standard equation for the parabola is y equals ax squared plus bx plus c. We then integrate the quadratic equation over the interval negative h and h to obtain the area under the parabola. After that, we then manipulate the coefficient y0, y1, y2. This process will give us the formula for the Simpson rule. The integral of f of x dx is approximated using the Simpson rule by taking delta x divided by 3 times the quantity f of x sub 0 plus 4 of x sub 1 plus 2 of f sub 2 plus 4 of x sub 3 plus and so on, plus 2 of f of x sub n minus 2 plus 4 of f sub n minus 1 plus f of x sub n, where the delta x is b minus a over n and n must be even. The pattern inside the sum is 1, 4, 2, 4, 2, ... and we end with 4, 1. That is 1, 4, 2, 4, 1, or 1, 4, 2, 4, 2, 4, 2, 4, 1, and so on. There is a symmetry there. Out of all of the numerical methods we use to estimate the integral, Simpson rule is the best of them all. It is the weighted average using 2 midpoint sum and 1 trapezoid sum. Since the Simpson rule uses even number of intervals, we would need to double the number of intervals in the midpoint and the trapezoid rule. Error bounds for Simpson rule. Suppose the absolute value of the fourth derivative of f is less than or equal to k for x between a and b. If E sub s is the error involved in using the Simpson rule, then the absolute value of E sub s is less than or equal to k times the quantity b minus a to the fifth power divided by 180 n to the fourth power.